Okay, so I'm going to give you a video about Sig Figs a little bit more. Hopefully it'll answer your question and why I picked the numbers that I did for doing the Sig Figs. Sig Figs are they sound like they're complicated, but they're really not. The thing that's teachers have a really hard time with it because they teach it as a technique and not as what it really stands for. You should really understand what Sig Figs are, and once you understand what Sig Figs are for, maybe, hopefully, you'll see why you need to have them, and what their Sig Fig, what the numbers that we use for. So, okay, first of all, I was in the dark with Sig Figs for a long time. Then one day it just clicked. Okay, so hang in there. Hopefully it'll click for you. So first thing, we have to look at measuring devices, our scales. Okay, suppose I have something I want to measure the mass of, maybe like a penny. I have two scales, one that measures to the thousandths, and I'll call that scale number 1. And one that measures to the tenths, and I'll call that scale number 2. All right, so I have, so here's 1 and here's number 2. Now I'd like to ask, which one of these scales do I trust the most? Now when I ask students this, they will usually pick number 1. And I'll ask them why, because they say, well, it has more numbers. I go, why? And they'll say, well, and I'll help you with it, but it tells me that there's more information, okay? And we are trusting that it's not made up information, that it's actual information that's real. Okay, well, we would like to give a score to each one of these guys, okay? And a high score would be, would give the highest one, the one that's more precise should get a higher score. So in this case, number 1 should get a higher score than number 2. So what number do we give it? You know, so do we do it ranking from 1 to 10, 1 to 5, or some other scale? When I ask students to do this, they may use the 1 to 10 ranking and give number 1 a score of 8, number 2 a score of 4. And I'll ask them, why did you pick those numbers? And they'll go, well, because number 1's better than number 2. And it's a little bit better, but not as much better, so I picked 4. Okay, and when you do that, you're kind of being qualitative. You're kind of guessing, all right? What we would like to do is we would like to have a quantitative way of scoring our Sig Figs, and it's really straightforward. Okay, so using these numbers, it's really simple. Okay, the first one has you simply count the digits in the measurement. Okay, and that is the ranking of the measurement's trustworthiness, or how much we trust it. So number 1 had a score of 5. It had 5 numbers, and number 2 had a score of 2. Okay, it's because it had 2 numbers. That's it. There's nothing more to it. It just says that I trust number 1 better than number 2. I'll give it a score of 5, and number 2 I'll give it a score of number 2. Now let's say I had another scale, maybe scale number 3, and it gives me a number like this. Well, what's its score? Well, count all the digits. It would have a score of 16. Okay? All right, so we call this measurement of trustworthiness, we call it significant figures, or Sig Figs, or significant digits. Okay. All right. Now let's take a look at the numbers a little bit more. We have to talk about this thing called a guess digit. Okay. It is important to understand a numerical measurement. So let's look at number 1 value. It had 2.456 grams. What numbers are we absolutely sure about in this measurement? Okay, well, we're sure about the 2, the 4, and the 5. But we're not really sure about the 6. And the reason why we're not so sure about the 6 is maybe it's a rounded number, okay? So if we look at the number I gave you for number 3, okay, that long number, the number that came after this number here was actually 2.45556 and so on. And so it looks like this number here, okay, was rounded up to 6 by the scale. So this number here, our last number, is kind of an estimate. It's a rounded number. So it's not absolutely right. It's based on all the numbers after it, okay? So what I like to do, I can't trust it, okay? So I call this digit a guess digit, all right? So I trust the 2, the 4, and 5, but not the 6. So if I don't trust it, why should I even have it, okay? Well, okay, so let's say you take it away because I don't trust it. So now I have 2.45, okay? All right. Well, is that right? Okay, is it 2.45? Well, look at this number. Actually, that last digit should be rounded up to 2.46. Okay, so if I knock off this 6, it still influences this number here, rounds it up to 6. But now I can't trust this number because it's not what it should be. Okay, it's not a 5. Okay, so I no longer can trust this number. I can trust the 2 and the 4. Right. The key thing is this: the last digit that you put down, what it does, even though it's imprecise, makes all the other numbers good. All right. So whatever number you put down here makes every other number good. So don't forget your guess digit. Okay. That's really important. Even though it's not precise, it makes all other numbers precise. So how do you measure, okay, if you have scales, okay, there's different kinds of scales. What numbers do we write down when we use the different scales? So if we have an electronic scale, it'll give us a list of numbers, write all those numbers down. So if you had a number like 2.450, okay, you would write down 2.450. 0 is a real number, especially when it comes to the electronic scales. All right, if you have a graduated scale, maybe like a ruler or a thermometer, you're always allowed to measure one digit, then you can read. So let's say I have a thermometer, and it's maybe it's like, okay, these are, so 1 degrees, 2 degrees, 3 degrees, 4 degrees, but it also gives you hash marks for the tenths, okay? Okay, so then let's say you had some temperature right here. Okay, you would write down 2 point, okay, whatever, so it's like 3. Okay, and we're sure about this 3 because if it's 1, 2, 3, so if we're sure about it, we're allowed to put one more digit. And it doesn't matter what you put. I don't know, I might put down 3, I might put down 0, 1, 2, doesn't matter. Okay, I'll put a 1. Okay, so whenever you have a graduate scale, write one more digit, go to one more digit, then you can actually read. For empirical values, write down all the digits they give you. You know, like the atomic mass, write down all the digits. For exact numbers, you don't have to worry about Sig Figs because they have an infinite number of Sig Figs. So if I say 1 liter is equal to 1,000 milliliters, all right, okay, you don't even you don't even deal with the sig figs here because these are exact relationships, okay? I'm not going to say this has 1 sig fig and this has 4 or whatever. Is that it doesn't matter because they're exactly, okay? So whenever you have exact relationships, don't count their sig figs. They don't count. Okay, so let's do some math with this now. So multiplying, dividing, and adding and subtracting. So let's do adding and subtracting first. So let's say I have 2 pennies, and I measure them on my 2 scales that I used in previously. And scale 1, I come up with a penny, and it weighs 2.456, and penny 2 weighs 2.50. All right. I add the 2 masses together, and the total mass is 4.956. Okay. Now, is this the number? Is this the number I should actually record? All right. So is this the right value? Okay. So before we go any further, let's look at what measured numbers are. Measured numbers are more than just numbers. Okay, not like a calculator just sees numbers. It doesn't see what measured numbers are. Measured numbers tell us 2 things. They tell us how big the number is and how precise it is. Okay. Kind of like a vector, all right? Where a vector has magnitude and direction. Our measured numbers have magnitude, how big, and precision. So, when you add the numbers together, you're showing just how big it is. You're not giving the trustworthiness of it. Okay, so what is the trustworthiness of this number? All right. We said that number 1 had a score of 4. And we said that number 2 had a score of 2. Okay, what should the answer? Should it be like an average of the 2, like 3? Okay, so we have to take a look at it. Have to figure it out. So and no, help me. So what help you understand this? Hopefully, is I like to use an analogy for track. Use coach track, and there's a race called a 4x4, when you have 4 athletes. Each one's to carry a baton around the track 1 time. Okay, so let's say I have 2 teams, and team 1 and team 2. And team 1 gets lap 1 done in 45 seconds, and team 2 takes 60 seconds. So after lap 1, team 1 is way ahead. It's 15 seconds. Okay, lap 2, same thing, okay? Beats them by 15 seconds. So at this point, after 2 laps, which is almost a half mile, it's 30 seconds ahead for number 1. So it surely looks like they're going to win. Okay, after 3 laps, they get the same thing. Now team 1 is 45 seconds ahead, which is almost a whole lap ahead. Okay, so and then number 3 gives, number 1 team gives it to their last guy, and the guy runs 2 minutes. Okay, while number 2 team still runs 60 seconds. Okay, when you look at the total time and see who crossed the finish line, team 2 wins, okay? You would have never thought it after lap number 3. So what determines who wins the race? It's not your fastest runners. It's your slowest runners, okay? So it's how slow your slowest runner is. It's the same thing with Sig Figs. It's not how good your best measurement is. It's how bad your worst measurement is. Okay. So number 2 has a score of 2, and number 1 had a score of 4. So our answer can only have the score of number 2, which had a score of 2, or sig fig of 2. All right. So what we have to do is change this number so it only has 2 digits, and so it goes to right here, the 10th, and you can see the 5 rounds it up, and so our answer is 5.0. Okay. Now some students go, well, what happened to those other digits? They don't count because you can only keep the digits that count for the precision. Okay. So when you figure out the number of sig figs and adding and subtracting, and we'll see same thing, multiplication, division, the number with the least number of digits determines the precision of your answer. So let's do another one. Let's say I have this number here, 0.00000012, and I'm going to add it to 1.21. And they're in the same units, whatever they are. And you get this number. Okay, so this is how big our number is. Now let's figure out the precision of this number. So what are the two sig figs of each of these, this number and this number? Okay, now this is a really important thing. When you use adding and subtracting and you get a number like this, okay, with leading zeros, you count all the zeros, all right? Okay, now that might contradict what you kind of might have learned before, and please watch the other video that I'm putting with here. This contradicts it, is that leading zeros we do count when we have adding and subtracting. So this would have 1, 2, 3, 4, 5, 6, 7, 8 digits. So this has 8 digits, and this has 3. Okay. Now, so don't use if you use what's, if you just look at the number all by itself, this would have only 2 digits. But in adding and subtracting, you have to count all the zeros. All right, so it has 8. All right, so now technically, actually, you only count the digits right of the decimal point. So so this would have 8. All right, and this guy would only have 2 digits. Okay, so your answer can only have 2 digits. So it's because this is the guy here, the least number of sig figs determines how many sig figs your answer can have. So your answer can only be 1.21. Okay. So if you're given a number like this, you count all the zeros, leading zeros. They count in the sig figs when you add and subtract. Okay, so this has a total of 8 digits. This one has a total of 2. That's not actually 2 because you count just the right of the decimal point. So the answer can only have 2, so it's 1.21. So it can have 2 digits right at the decimal point. Now, this may look odd because we took 1.21 and added to that other number, and our answer is still 1.21. How can our number be the same as what we started out with? Okay, well, think about it. The number we added, that really small number, really hardly changes this 1.21 at all. Okay, so it's like if you were weigh a car, maybe if it weighs like 3,331 pounds, okay, and then you put a feather in it and weigh it again, it's still going to weigh 331 pounds, okay. Okay, so so that 0.000012 really doesn't affect the mass of our measurement, especially with the precision that we have. Okay, now let's look at multiplying and dividing. This is similar, but we need to have a slightly different set of rules for getting our sig figs. Now in the other video, it tells you how to get sig figs just by looking at the number. So when you look at a number without doing any kind of calculations, the other video tells you how to do that. talks about zeros and so forth. So pay attention to that. Okay. Now, those rules don't apply when you get to adding and subtracting. Okay. There's different set of rules because, especially for leading zeros. But the rules that in that video apply to multiplying and division. So let's say I have two numbers, 2.37 times 788.33. And I wanted to get its bigness and its precision. So first thing I'll do is I'll multiply it. Come up with this. Now figure the sig figs. Okay, so now you count all the digits. So this has 1, 2, 3, and this has 1, 2, 3, 4, 5, 6. So I have 3 sig figs and 6 sig figs. So our answer can only have 3. Right? So I can go here, here, and here. So I have 1, 8. Okay, and now I write another number here, but this 8's going to round it up. So I'll write 187. But you can see that I have to put another number here, or that tells me it goes to that this is the ones. Okay. Now you can put a 0 there. Okay. But you have to remember it's a placeholder, so you can put a cross through it, or you can put a line over it to show that it's placeholder. So it'd be 1870. So there's 3 sig figs here, and there's a placeholder. Okay. Right. This is awkward. It's you know, if you run 187 and then have this 0 as a placeholder, it's awkward to do that. So when you do multiply and division, it's really best to put it into scientific notation first. Okay. So here's what I did. 2.37 times 10 to the 0, which is 1. 7.8833 times 10 to the second. Okay, so what you can do is whenever you do these kinds, you can multiply this guy times this guy and get 18.6834921. Then multiply the exponents, so you get 10 to the second. And then change the scientific notation, you get 1.86834921 times 10 to the third. All right, so this has 3 sig figs, okay, and this has 1, 2, 3, 4, 5, 6. So your answer can only have 3 sig figs. So your answer is going to have 1, 8, 6, round up to 7, so it's be 1.87. Now you don't have to worry about that placeholder, okay, times 10 to the third. Okay, there you go. Okay, let's do another one. 0.000034110 times 14,222.34300. Okay, so change its scientific notation. So this becomes 3.4010 times 10 to the minus 6. Okay, remember any zeros, this 0 does count, okay. And it has 5 sig figs. 1, 2, 3, 4, 5. Okay. And then change this sig figs. 1.422 times, 343,000 times 10 to the fourth. This has 11 sig figs. Okay. And so there's 11 here. So right, multiply them together, and we get this number here. Okay, our number can only have 5 sig figs. It's the least number, so it can go 1, 2, 3, 4, 5. Okay, this 8 rounds this up to 4, so it's going to be 4.8374 times 10 to the second. And finally, okay, don't use scientific notation when adding and subtracting. Convert it out to their numbers. So, for instance, if you had this operation, 6.1 times 10 to the third plus 9.44 times 10 to the minus 8, don't add those together. Okay, it's too hard. Okay, you just can't add 6.1 and 9.44. Okay, so what you have to do is you need to turn them to their number. So this is 6100, and this is this number right here. Add them together. Okay, this has 2 digits. Okay, and this has 3 digits. You're only allowed to have 2 digits. So your answer is going to be 61, and then these 2, so it's going to be 6.1. You can leave it at 6.6100. The placeholders are 6.1 times 10 to the third. Okay. All right. I hope that helps you out. Let me think about a couple problems that I can give you, but please watch the other video that I linked you here as well to help you. That one will deal with numbers just when you look at them, okay, not when you do operations. Okay, that's all.